Second end of diode is connected to this component and this component. It is transformer winding. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. I received these two comments from my viewer. It is from my channel member. I am thankful for every channel member who is paying membership fees to support my channel. I am one of your follower. Could you please assist to do a video on SMPS that uses BJT transistors to create self-oscillation? Then the second comment, I see most of explanation on SMPS is on IC providing the pulse on the base, or some SMPS uses just IC, or some SMPS ICs do the pulsing. But I want to understand the old way of oscillation on SMPS uses discrete transistors. For that purpose I will use this small power adapter. It is 5 volt adapter and it provides oscillation using this single transistor. In some circuits there are 2 transistors, but here it is using just only one transistor, that is high voltage transistor. It uses optocoupler, auxiliary winding, primary winding and very few components, and in the output side it provides regulated voltage. If you have not subscribed my channel, subscribe it, and then press notification for all, so that you will be notified for all new updates from my channel. And if you want to take membership, you can press join button. There are different options. You can pay monthly. Here is line neutral. These 2 points, line neutral. This one is reaching here at this diode directly. Cathode of this diode is reaching to positive terminal of the capacitor. Check this point. It is coming here. Then from here to here there is one component, that is this fuse. Orange, black, gold, 3 ohms, and it is burned out, and it is also disconnected from this point, and it is reaching to capacitor negative terminal. That means it is using just only half wave rectifier, one diode. So I connected diode here. This is 3 ohm resistor, positive, negative. 4.7 microfarad, 400 volt. 4.7, 400. Neutral fuse resistor, and this is negative terminal. This is positive terminal. And this diode, positive terminal. The positive terminal is starting from here, capacitor positive, this component, and this component. Now if you see positive line, 1, 2, 3, 4, 5, 6. If you see the last node, it is transformer primary winding. This one capacitor, and the second one resistor. Resistor and capacitor, one end is connected to positive terminal. Then if you see this one, here is also one component in this line, I think, that is resistor, capacitor, resistor, and the third component transformer winding. Same line, one capacitor, one resistor. Second end of this capacitor is connected to two more components. Capacitor, this end is connected to this resistor. So both components are in parallel. These both components are parallel. Then these are connected to another component, that is this one. This is resistor end, this is capacitor end. This is diode, D2 diode. And we will write the value of the components. Second end of diode is connected to this component and this component. It is transformer winding. And second side is connected to this 13003 transistor. Center pin, that is collector. D13003 transistor. And now we have one component here, that is this one, that is resistor, yellow, violet, yellow, 470K. This resistor, 470K resistor, is reaching to base pin of 13003 transistor. (470K resistor). Value of this resistor 8230, 82K. 82K. Capacitor value 472 code, 1 kV, 4.7 nano, 4 and 2, 1 kV. Now negative terminal is reaching to this point, this point, this point, and this point. If you see this, it is auxiliary winding one end here as primary ground. If you check this point, that is after fuse resistor, and it is positive terminal of the capacitor. Capacitor positive terminal is grounded. Now if we check this point, we can see this line is now coming here. What is here? Here is a resistor. Resistor second end is connected to emitter pin of 13003. Emitter, collector, base. Value of this resistor is 68 volt, 6.8 ohms. 6.8 ohms. And here is also one component. It is D3 diode, 4148. So cathode is connected in this way. Cathode is connected to base pin. (4148). It is reaching to this diode D3, then it is reaching to this point. Here is C3 capacitor. C3. C3 second end is connected to another component that is closer to C3. Brown, black, brown. It is reaching to transformer winding. There is another component. Here is D4 diode, 4148. And second end is connected to this capacitor. Anode of this diode is connected to this capacitor, negative terminal. Capacitor value 10 microfarad, 25 volt. This point is connected here, optocoupler, PC817. Optocoupler pin 1, 2, 3, 4. Pin number 3 is emitter of the transistor. 1, 2, 3, 4. collector is reaching to this point, that is going to base. If you see transformer secondary winding, it is reaching to this point and it is reaching to this point and this component. 1, 2, 3, 4 connections on this winding line. Here one resistor, R6 resistor, and if you look at this side, this diode, D5 diode. And it is reaching to capacitor positive terminal, that is here. D5 capacitor positive terminal, and capacitor this end is connected to ground, and as we discussed 470 60 volt, 16 volt. Then this component, here is a resistor. This resistor is coming here and it is coming to output positive terminal. 1.8 volt, 1.8 ohms. If you see this point, it is reaching to this component, A733 to SA733 PNP transistor, emitter, base, collector. Now if we check this line, negative terminal, we have this resistor. It is coming to LEDs. Value of this resistor is 560, 560 ohms. And if we check this side of LED, it is connected to positive terminal of the capacitor. This positive terminal of the capacitor is connected to this pin. It is emitter of this Q2 transistor. SA733. Sorry, here is correction. Emitter, collector. Collector is connected here. Positive terminal is reaching to collector. Positive terminal is also directly reaching to emitter. It is working as a shunt regulator. At this point there is a component. It is ZD1. Cathode is connected to positive terminal and anode is connected to base. Capacitor positive terminal from here, this zener, it is reaching at base. Second end, base second end is reaching to here. So, and here is a resistor 1000 R71K. One kilo ohm. Second side of this resistor is connected to this point, and there is a component in this zone, that is this diode, that is D6. It is reaching to this diode, then output point, negative out, and at this point this resistor is connected. This point It is pin number 1 of optocoupler. Pin number 1 is connected to this resistor, one end, and pin number 2 is connected to this resistor, second end. This is coming to this point, and ground line is connected to here. LED second side is connected to positive output terminal. When we see practically circuit on the PCB, it is too much difficult, but when we see on paper, it is easy to understand. Although it is not a good drawing here, because in reverse engineering, first you have to make a conceptual layout. After that, these components will be arranged in a logical format. So I will rearrange this circuit, and in upcoming session I will place the components on this diagram, and we will power on this circuit on this diagram. Let's see the function. Line neutral. Voltage will be rectified, this capacitor. Then this voltage will reach here at this resistor. Now we will see this capacitor is discharged. 102 volt, that means 1 nanofarad capacitor. Positive voltage will reach here at the base. This time this emitter is grounded. It is low, and here these positive voltage will come here and it will start to charge this capacitor positive, and this side is grounded. When this current will flow, voltage level will increase on the base. Base to emitter current will flow. When this junction will start to conduct, high current will flow in this zone. When emitter current will start, collector current will also start. That time it will start to build magnetic field here. When it will start to build magnetic field here, same time it will induce voltage in this winding, and it is in phase. When it is in phase, now we can see same positive voltage will start to build up here. When it will start to build up here, this end will become positive. When it will become positive, it will start to draw more current here. This transistor will move in saturation, so more conduction. When more conduction, more voltage will here. When it will provide voltage in this winding, this diode will rectify the voltage, this capacitor will charge. Here we have this Zener regulator. It will provide conduction to this LED, that is optocoupler LED. Second end of LED is connected to negative side. That time this optocoupler will start. Now these voltage, auxiliary winding voltage, are being rectified and started to charge this capacitor. Now this capacitor is in opposite polarity. Positive end is grounded, negative terminal, this side, is connected to emitter of this transistor. When voltage are maintained, this negative level will reach to the base. NPN transistor base will become negative. It will pull down to turn off base to emitter junction. When base to emitter junction will become in non-conductive mode, at that time this current will stop. This time this voltage stored on this capacitor will run the load. As soon as the LED is released from conduction, because when voltage will drop, it will release this transistor. When it will turn off, at that time this line is now blocked. Again this end will start working. It will start to move in conduction, and it will assist to move in saturation, so that this transistor will start oscillation. First oscillation from this voltage, and then it will move to conduction. This winding will assist to turn on. When it will turn on, more and more magnetic field will transfer voltage in secondary. When the voltage are built up at required level, this LED will turn on. It will conduct this transistor in the optocoupler body. So it will turn off this transistor. Here is RCD snubber. RCD snubber will demagnetize the winding when its magnetic field will collapse in off state. When transistor will off, this end will become positive. Before this end is positive, this end is negative. But now this end is positive. It will charge this capacitor and this voltage will be discharged in this line. If this video is informative for you, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.